Okay, welcome to the first in our series on the ER diagram or the conceptual model. In fact, why don't we go ahead and define our mystery word? Let's make it conceptual model for this video. Once again, based on the book by Masri Navath, Fundamentals of Database Systems, the 6th edition. So let's get started. Conceptual modeling is a very important phase in the design of successful database applications. Generally, the term database application refers to a particular database and its associated programs that implement the database queries and updates. Therefore, a major part of the database application will require the design, implementation, and testing of these application programs. Traditionally, the design and testing of application programs has been considered part of software engineering rather than database design. Some of you have probably taken a course or will be taking a course in C or Visual Basic or Java in which you'll be developing applications that manipulate a previously defined database. In many software design tools, the database design methodologies and software engineering methodologies are intertwined since these activities are strongly related. For our purposes in this series on conceptual modeling, we will follow the traditional approach of concentrating on the database structures and constraints during conceptual database design. We'll be discussing modeling concepts of the entity relationship model or the ER model, which is a popular high-level conceptual model. We'll also talk about the diagrammatic notation associated with the ER model known as ER diagrams. Other modeling methodologies such as unified modeling language are becoming increasingly popular in both database and software design. These methodologies go beyond database design to specify detailed design of software modules and their interactions using various types of diagrams. The first step to designing a database is requirements collection and analysis. During this step, the database designers interview prospective database users to understand and document their data requirements. A number of tools can be used to accomplish this, including interviews, questions, and my personal favorite, following the paper. There aren't many better ways to find out what kind of data an organization uses than gathering together various statements, invoices, and reports, which I call following the paper. The result of this step is a concisely written set of users' requirements. These requirements should be specified in as detailed and complete a form as possible. In parallel with specifying the data requirements, it is useful to specify known functional requirements of the application. These consist of the user-defined operations or transactions that will be applied to the database, including both retrievals and updates. In software design, it is common to use data flow diagrams, sequence diagrams, scenarios, and other techniques to specify functional requirements. Once the requirements have been collected and analyzed, the next step is to create a conceptual schema for the database using a high-level conceptual data model. This step is called conceptual design. The conceptual schema is a concise description of the data requirements of the users and includes detailed descriptions of entity types, relationships, and constraints. These are expressed using the concepts provided by the high-level data model. Because these concepts do not include implementation details, they're usually easier to understand and can be used to communicate with non-technical users. The high-level conceptual schema can also be used as a reference to ensure that all the user's data requirements are met and that the requirements do not conflict. This approach enables the database designer to concentrate on specifying properties of data without being concerned with storage and implementation details. This makes it easier to create a good conceptual database design. This is the phase in which the database designer cooperates closely with the end user to come up with the conceptual design for the database. During or after the conceptual schema design, the basic data model operations can be used to specify the high-level user queries and operations identified during functional analysis. This also serves to confirm that the conceptual schema meets all of the identified functional requirements. Modifications to conceptual schema can be introduced if some functional requirements cannot be specified using the initial schema. The next step in database design is the actual implementation of the database using a commercial database management system. Most current commercial database management systems use an implementation data model, such as the relational or the object relational database model. So the conceptual schema is transformed from the high-level data model into an implementation data model. This step is called logical design or data model mapping. Its result is a database schema in the implementation data model of the database management system. Data modeling mapping is often automated or semi-automated within the database design tools. The last step is the physical design phase, during which the internal storage structures, file organizations, indexes, access paths, and physical design parameters for the database files are specified. In parallel with these activities, application programs are designed and implemented as database transactions corresponding to the high-level transaction specification. Okay, I believe that's enough content for this video. So why don't we take a break right here, submit your mystery word, go to our coursework area and check your knowledge on the first video on ER diagramming. And when you're ready, come on back to the second episode or the second video in this series on the ER diagram in relational database design.